So the last application that we'll get to talk to about integration in terms of this course will be as an introduction to what are known as differential equations. And differential equations are actually sort of the equations that a lot of people use to describe the world that we're living in, whether it's equations stemming from physics, from biology, chemistry, even economics, to other types of ideas in modeling, like, say, modeling the stock market, modeling diseases, modeling how fluid flows in our hearts, in our bodies, and things of that nature, how things swim, how things fly. Differential equations are used all around us in the real world. So what we get to do today is basically do our first introduction to this entire field of differential equations. And now I could go on and on about this field. This is basically what I've dedicated my professional nerdy mathematician life to, but I hope to give you a sense of why I find these equations exciting and what type of powerful information we actually get from these things. So I know I've just rambled for a little bit. So without further ado, what a differential equation is an equation that involves one or more derivatives. So this is a little different than equations we've seen before. So for example, just as kind of a random example here, we could have a differential equation that's something like the second derivative of our function y with respect to x plus 5 times the first derivative of y with respect to x plus 3 times y itself is equal to, say, cosine of x. So this equation, well, this is a little bit above our pay grade in Calculus B, but this is an example of a differential equation. We have an equation that has a second derivative in it, a first derivative in it, and so on. So any type of equation which involves one or more derivatives is called a differential equation. Now, where we're going to start in our course is revisiting some of the ideas from Calc A about what derivatives tell us. So a lot of the differential equations we'll be thinking of in this class will be things like, say, dp dt, so some dependent variable p that depends on the independent variable t in that denominator is equal to, let's just say something like, this is equal to 5 times p times 1 minus p itself. And the questions that we start asking in terms of Calculus A is we focus in on this derivative term. And some of the things derivatives told us in Calc A were things like, number one, what does it mean when the right-hand side or our derivative is positive? Or what does it mean when our derivative, say dp dt, is negative? What does that mean about the solution p with respect to time? Or what does it mean when our derivative is equal to 0? So for example, when the derivative is positive, we know our function p increases, which literally means if we had some sketch of p against our independent variable t, it would just mean at some point the derivative is positive or the function's increasing. Similarly, well, I guess opposite, if dp dt is negative, our function p of t decreases. Literally just meaning that p at some point starts to go downwards. Now, if dp dt is equal to 0, what that means is our solution p of t is constant. So this is just to give you an idea of some of the information that Calculus A ideas give us. Basically, what is happening on that right-hand side of our derivative, dp dt, tells us, hey, we know something about the solution, p. Is it increasing, decreasing? Is it constant? And that can all be discerned from investigating the right-hand side of this differential equation. When that right-hand side is positive, it increases. When the right-hand side is negative, p decreases. When the right-hand side is 0, p remains the same and is constant. So those are some of the ideas that we'll start investigating of how we can think about differential equations very much in a math modeling sense. How can we use these types of ideas of derivatives to describe things in the real world? So what I want to do in our short introduction to differential equation is revisit some of these ideas from Calc A, relate them back to how we can use derivatives to start modeling and thinking about the real world, and introduce the first solution technique that we're going to use in our course. And in Calculus B, the solution technique we're going to use is something called separable equations method. And basically, this is going to involve integration, as this is an application of integration. And some of the other ideas that we'll see in this segment of the course is we'll finally see what that integration constant, the plus c terms, can be used for, as well as we'll start being able to tell the difference between different types of solutions to differential equations called implicit or explicit solutions. In the next video, I'm going to go over a very quick example of how the method of separation, or the separable equations method, can be applied. So check it out.